Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we are going to be starting Unit 5. And Unit 5 is kind of cool because it builds on our skills from Unit 4. We're going to still be doing a lot of factoring. When we had to find the zeros in Unit 4, that's also going to come in handy in what we do in Unit 5. So before we get started, don't forget to put your first and last name, period, and the date in the upper right-hand corner of your notes. We're starting with Unit 5, Lesson 1. Our main topic is simplifying rational expressions. And I'm going to explain to you what a rational expression is in just a minute. So our objective today is I will reduce, multiply, and divide rational expressions, as well as state any restrictions on the variable. Mastery will be demonstrated by scoring at least 80% on the extra practice. So before I give you the definition of a rational expression, I want to show you an example of what a rational expression is. So rational expression, I'm going to go to the simplest form box here, is a polynomial divided by another polynomial. So it's a fraction of polynomials. So what does that mean? Let's say you have x plus 1 divided by x minus 1. So x plus 1 is a degree 1 polynomial. X minus 1 is a degree 1 polynomial as well. And they're being divided by each other. So it's a fraction made up of polynomial expressions. Another example of a rational expression might be x plus 2 times x plus 1, all divided by x plus 3. Another rational expression could be 2 divided by x. And all three of these examples are in simplest form. That means they cannot be simplified any further. Now, a rational expression that could be simplified, so an example of a rational expression that's not in simplest form might be x divided by x squared. Now, the reason why this isn't in simplest form is because this is a fraction that can be reduced. So x over x squared is the same thing as x over x times x. Well, what is x divided by itself? X divided by x, isn't that just 1? So x over x squared ends up simplifying to 1 over x. So x over x squared is not in simplest form, but 1 over x would be. Another example would be 3 times x minus 3 all over x minus 3. Well, x minus 3 and x minus 3 are in the numerator and the denominator. X minus 3 divided by itself cancels because x minus 3 divided by x minus 3 is 1. So up top, you just have 3 times 1, which is 3. So 3 times x minus 3 divided by x minus 3 is not in simplest form, but if you did end up reducing it, you would just have 3. Let's do one more. So another example of a rational expression could be x minus 3 times x plus 2 divided by x plus 2 times x minus 1. So again, x plus 2 and x plus 2 are in the numerator and the denominator. X plus 2 divided by x plus 2 would simplify, leaving us with x minus 3 divided by x minus 1. Now, here's the thing. I always have kids who want to take this x over x and simplify it. You're not allowed to do that because what you have is x minus 3 divided by x minus 1. The x is being subtracted from the 3, or the 3 is being subtracted from the x, and this negative 1 is being subtracted from the x. These two things are like stuck together. They're their own piece of this rational expression, and you have to be able to divide that whole piece and simplify that whole piece. So x minus 3 over x minus 1 can't be simplified further. All right, but I'm going to erase that because I just want you to see examples that aren't in simplest form. All right, so now let's talk about the official definition of a rational expression. So a rational expression is the quotient of 2 or more polynomials. Okay. And what that means is quotient is just two things being divided by each other. So that's just a fancy way of saying that you're taking one polynomial and dividing it by the other. So there's something we have to talk about, and that is the denominators of a fraction. So remember, anytime you have a fraction, like the fractions you're used to dealing with before rational expressions are fractions that look like 2 over 3, 2/3, 1/5, 7/8, 9/5, 3/4. Fractions that look like that. What are we never allowed to have in the denominator of a fraction? The only number that we're not allowed to divide by is 0. So the denominator of a fraction cannot be equal to 0. That's not allowed. It can't be equal to 0. Same thing goes for a rational expression. The denominator is not allowed to be 0. It cannot equal 0. It's not allowed. So if we look at our rational expression, x plus 1 over x minus 1, what would happen if we plugged in x equals 1? Well, we would get 1 plus 1 over 1 minus 1. 1 plus 1 is 2. 1 minus 1 is 0. So for this rational expression, x is not allowed to equal 1. Because if you plug 1 in, you get 0 in that denominator. So x can't be 1 for x plus 1 over x minus 1. So we're going to be stating restrictions on the variable for all of our rational expressions. So, and we'll get into that when we do some more examples in just a second. Now we've kind of already talked about what simplest form looks like. But I just want to officially say rational expressions in simplest form, the numerator and denominator have no common factors. All right. So let's jump to example 1 here. Example 1, 70x squared divided by 28x. All right, so 70x squared over 28x. Now, to simplify this, we are going to write out all the factors. So 70 is really 7 times 10, x squared is really x times x. Over 28 is 7 times 4 times x, and then 10 can be broken down and 4 can be broken down to 2 times 5 and 2 times 10. So now we're going to cancel all of the like factors because 7 divided by 7 is 1. 2 divided by 2 is 1. And x divided by x is 1. So what's 1 times 1 times 5 times 1 times x? That would just be 5x over, and then all that's left in the denominator is a 2. So 70x squared divided by 28x simplifies to 5x over 2. But we also have to state our restrictions on the variable. What is x not allowed to be? So as you can see in our answer here, there's no variable in the denominator. However, in the original expression, there is a variable in the denominator. So we have to state our restrictions, and they have to include any restrictions on the original rational expression. So 28x, what would make 28x equal 0? Well, divide both sides by 28, x equals 0. So if we plugged in 0 for x into the original expression, let me show you. So 70x squared over 28x. If we took 70 times 0 squared divided by 28 times 0, we would end up with 0 over 0. We're not allowed to have 0 in the denominator. That means that x can't be 0. Because when I plugged in 0 for x, I got 0 in my denominator. So 5x over 2, and then you put a comma, and then you state the restrictions. So 5x over 2, and x cannot equal 0. All right, now you try. So 16r squared over 24r cubed. I want you to simplify this completely and then state your restrictions on the variable. All right, go ahead and press pause and then press play when you're ready to check your work. So I broke down 16r squared to 4 times 2 times 2 times r times r. 24r cubed is 4 times 2 times 3 times r times r times r. So I see that these 4's will cancel, the 2's, and then 2 of these r's. So what I'm left with is 2 in the numerator and 3r in the denominator. Well, if 3r is in the denominator, and I don't want 3r to equal 0, I don't want my denominator to equal 0, I'm going to divide both sides by 3. R then can't be 0. If I plug 0 in here, I'm going to get 2 over 3 times 0, which is 2 over 0, and that's not allowed. So R cannot be 0. And what's nice about that is it's the same restriction as the original expression that we started with. Because if you plug in 0 for R, so if you have 16 times 0 squared over 24 times 0 cubed, 0 cubed is 0, and 0 times 24 is 0. So we'd end up with 0 over 0, which isn't allowed. So our answer is 2 over 3r, and r cannot be 0. So the restrictions on the variable are what r can't be, or what x can't be. They can be any number but 0. They can be any number but that restriction. All right, so let's do 2x minus 4 over x minus 2. So this can't be simplified on the surface. It's like 2x minus 4 over x minus 2. Those aren't the same factors. This can't be simplified. But what if I factored the numerator? 2x minus 4. Well, 2x and 4 both have a 2 in common. And if I factor that out, I'm going to get 2 times 2x. So I want 2 times x to get 2x, and then 2 times negative 2 to get negative 4. We'll check it out. X minus 2 divided by x minus 2 cancels, and I'm left with 2. Now look back at the original function. Our answer, not function, sorry. Look back at the original expression. Our answer doesn't have an x in it. We're just left with 2. But the original expression had x minus 2 in the denominator. Well, what would make x minus 2 equal 0? X equals 2. So x can't be 2. Oh, wait. But our answer, no, that's fine. 2 and x can't be 2. That's fine. Those two things can match. It's okay. All right, part D. So 45 over 10x minus 10. So you're going to factor this thing, you're going to simplify it, and then you're going to state any restrictions on the variable. Go ahead and give it a shot. Press pause and then press play when you're ready to check your work. All right, so I factored 45 over 10x minus 10 to 5 times 3 times 3, it's 45. 10 times x minus, oh, you know what? That was silly of me. That should be x minus 1. Huh. Okay, yeah, because 10 times x is 10x, 10 times negative 1 is 10. My bad. All right, so then I broke 10 down to 5 times 2, and then this should be x minus 1. I'm glad I fixed that. Good catch, McGuire. All right, so 5 divided by 5 cancels. So I'm left with 3 times 3 over 2 times x minus 1. So I'm left with 9 over 10 over 2 times x minus 1. which means x can't be 1. And we need to check the original expression that we started with. Well, 10x minus 10 factored to 10 times x minus 1. And 1 would make this 0, so we're good. We've listed all of our restrictions. So x can't be 1. And if we want to double check that, we could take 10x minus 10, here I'll do that to the side, and set that equal to 0. We'll add 10, divide by 10, and you get x equals 1. All right. Hopefully our answers match. Okay, so now we're going to get into some more fun rational expressions, a little more challenging, if you will. So what we're going to have to do is x squared plus 7x plus 10 over x squared minus 3x minus 10. We're going to have to factor this expression. So the first thing we're going to do is factor. The second step is to simplify as much as you can. And the third step is to state restrictions. So let me show you what this looks like. So x squared plus 7x plus 10. Now, if you can't factor in your head, then you need to factor by grouping. And if you need me to remind you how to factor by grouping, hit the ask for help button in your breakout room and I'll hop in and help you factor this. But for the sake of doing this lesson as quickly as possible, I'm gonna remind you how to factor in your head. So x squared plus 7x plus 10 is gonna factor to 2 sets of parentheses, right? To get x squared, we would multiply x times x. To get 10, I'm gonna look at my factors of 10. So my factors of 10 are 1 and 10, 2 and 5. Which of those factors will add or subtract to get me 7x in the middle? 2 and 5. So I know I wanna use 2 times 5. And then for the signs in between, I can either do positive or negative. So I know I want a positive 10 when I multiply, a positive 7 when I add. Both signs will be positive. So I have x plus 2 times x plus 5. Now x squared minus 3x minus 10 will factor 2. So x times x is x squared. And then for 10, again, I'm either going to use 1 and 10 or 2 and 5. 2 and 5 will get me to 3x. To get a negative 3x, I'm going to subtract 5 and add 2. And if you need me to help you with factoring, again, hit the ask for help button. I'll jump in and help you out. Now we need to see if any of these factors will simplify. X plus 2 times x plus 5 all over x plus 2 times x minus 5. Well, x plus 2 divided by itself cancels. So we're left with x plus 5 over x minus 5. Now, the restriction on the variable is obviously, well, what would make x minus 5 0? That would be 5. You can't do that in your head. Again, set x minus 5 equal to 0 and solve for x. And you get 5. So it can't be 5. But remember, we need to look at our original expression. Our original expression also contained x plus 2 in the denominator. Well, what would make x plus 2 equal to 0? X equals negative 2. So we also have to do x can't be 5 and it can't be negative 2. All right. Why don't you give part B a shot on your own? So x squared plus 2x minus 8 all over x squared minus 5x plus 6. Before you give this a shot on your own, let me remind you how to factor by grouping. So you take a times c, so you'd have 1 times 8. Then you take your factors of 8, and you pick factors that will add or subtract to give you b. 2 and 4 will add or subtract to give you 2. So you're going to have x squared, you're going to have 4x, you're going to have 2x, and negative 8. To get a positive 2, you're going to have positive 4x minus 2x. Then put parentheses with a plus sign in between. Factor out what they have in common. So don't forget to do that for your denominator as well. So you're going to take 1 times 6. You're going to pick factors of 6 that add or subtract to give you -5. I'm going to go back to my numerator though. Okay, so, and then you just factor out what they have in common. So our numerator will be x times x plus 4. These guys have a -2 in common. You're going to have x plus 4. Our parentheses match. So you're going to have x plus 4 times x minus 2 as your factors. And if you can factor these in your head, that's great. Now don't forget to do your denominator. So whatever you're going to expand that denominator to 4 terms, and you're going to factor it and then put it here. All right, go ahead and give it a shot. Press pause and then press play when you're ready to check your final answer. Don't forget to state the restrictions on your variable. All right, let's talk about what I did here. So I expanded -5x as -2x and -3x. Put my parentheses around the first 2 terms, the second 2 terms, plus sign in between. Again, I'm just reminding you how to factor by grouping in case you don't know how to factor in your head. So I brought out an x from the x minus 2, so from the x squared and the -2x. I brought out a -3 from the -3x and the 6. And then I got x minus 2 times x minus 3 in the denominator. X minus 2 divided by x minus 2 cancels. So we're left with x plus 4 over x minus 3 with the restrictions that x can't be 3, right? X can't be 3, and it also can't be 2 because of x minus 2 in the original expression. So we've got 2 restrictions. All right, let's keep going. So now we're going to multiply rational expressions, and then we're going to state any restrictions on the variables. So before you start multiplying and dividing, what I recommend is that you factor and simplify your fractions first. So factor and simplify first. All right, so x squared plus x minus 6 over x minus 5, x squared minus 25 over x squared plus 4x plus 3. So we're going to factor and simplify first. So x squared plus x minus 6 over x minus 5 times x squared minus 25. We're going to factor that over x squared plus 4x plus 3. All right, so we have a lot of factoring to do. So x squared plus x minus 6. So I'm going to have x times x to get x squared. Then I'm going to have my factors of 6. So 1 and 6, 2 and 3. Which of those add or subtract to get me this 1x in the middle, 2 and 3. I want a positive 1, so I'm going to have positive 3 minus 2. All right, now let's do x squared minus 5. It's a difference of squares. We know how to factor that in our head. We have x times x, 5 times 5. 1 needs to be positive, 1 needs to be negative. All right, then x squared plus 4x plus 3. So we're going to factor this one. X times x will get us x squared. And then the only factors of 3 are 3 and 1. And then we're going to have positive 3, positive 1 to get 4 in the middle. All right, so we factored it. Now we're going to simplify what we can. So I see an x plus 3 and an x plus 3. Actually, hang on, let me show you real quick why this will work. So we're taking x minus 2 times x plus 3 times x plus 5 times x minus 5. So what that looks like is x minus 2 times x plus 3 times x plus 5 times x minus 5. All over. Then we have x minus 5 times x plus 3 times x plus 1. So I know I can do that because if you recall, when you multiply fractions, like if you had 2/3 times 5/8, when you multiply fractions, you multiply across. So 2 times 5 would be 10, 3 times 8 is 24. So I'm doing the same thing. All I did was I multiplied across and combined them into one fraction. So now I'm going to simplify. I'm going to take x minus 5 divided by x minus 5, x plus 3 divided by x plus 3, So we're left with x minus 2 times x plus 5 all over x plus 1. Now we need to state the restrictions on the variable. Well, in our solution here, in our final expression, sorry, it's not really a solution, it's an expression, x can't be -1 because -1 plus 1 would get us 0 in the denominator. So we know that we don't want x to be -1. But in our original expression, we had more than one factor. We also had x minus 5, and we had x plus 3. The -1 covers this part. But we also need restrictions for x plus 3 and x minus 5. You always have to look at the original expression. It's just the rules of the game. X can also not be 5, and it can't be -3. All right. So why don't you go ahead and try part B on your own? So you're going to take 2x minus 8 over x squared minus 16 times x squared minus 25 over x squared plus 4x plus 3. And I want you actually, actually, I want you to change x squared minus 25. Because apparently I just copied and pasted the second half of that problem. Let's do x squared minus, let's do x squared minus 9 instead of 25. All right, so press pause, then press play when you're ready to check your work. Remember, you're gonna factor it and simplify it as much as you can in that first step. All right, go ahead and give it a shot. All right, so I factored 2x minus 8 to 2 times x minus 4. X squared minus 9 is x minus 3 times x plus 3. X squared minus 16 is x minus 4 times x plus 4. X squared plus 4x plus 3 is x squared x plus 3 times x plus 1. So a lot of things simplified right away. X minus 4 divided by x minus 4, x plus 3 divided by x plus 3. So I'm left with 2 times x minus 3 over x plus 4 times x plus 1. So my restrictions are -1, -4, and then we have to look at the original expression. So we already have the -1, but then x plus 3 would also have a restriction on -3, and then x minus 4 would also have a restriction on +4. So my answer is 2 times x minus 3 over x plus 4 times x plus 1, and x can't be -1, -4, -3, and 4. All right, so that's multiplication. Now let's do division in example 4. So we're going to divide these fractions, and we're going to state the restrictions on the variable again. So division is easier than it looks. So I don't know if you recall, but if you took like 2/3 and you divided it by 5/4, you can change the division with fractions to multiplication. You just have to flip the second fraction. So we're going to do the same thing with this rational expression. We're going to keep 2 minus x over x squared plus 2x plus 1. We're going to change the division to multiplication. Then we're going to flip the second fraction. So step 1, change to multiplication. Step 2, factor it and simplify. Step 3, we are going to state restrictions. So let's do it. So 2 minus x. Well, anytime you have the variable second, we're going to rewrite that. So we have -x plus 2 over, and then times. I'm going to factor these guys if we can. All right. So x squared minus x is x plus 1 times x minus 1. X squared plus 3x minus 10. X times X will get me X squared. 5 times 2 will get me 10. If I add 5 and subtract 2, I'll get positive 3 in the middle. All right, then X times X is X squared. 1 times 1 is 1. And then if I add both of those, I'll get 2. Now, negative X plus 2, we can factor that because the first term is a negative. So I'm going to factor out a negative 1, and I'm going to get X minus 2. X plus 1 times X minus 1. X plus 1 times X plus 1. X plus 5 times X minus 2. All right. So now I see X minus 2 divided by X minus 2 will cancel. X plus 1 will cancel. So I'm left with a negative 1 times X minus 1 over X plus 1 times X plus 5. And my restrictions are X can't be, let's see, negative 1, negative 5, because if I plug negative 1 into that, I'll get 0. If I plug negative 5 into that, I'll get 0. And then if I look at the original expression, I also had, let's see, I already have negative 1, so I'm good. Negative 5, and then positive 2. All right. Why don't you try this one? So remember, step 1, change it to multiplication. Step 2, factor and simplify. Step 3, state your restrictions. Go ahead and press pause and then press play when you're ready to check your work. Good luck. So the first thing I did was I switched the division to multiplication, and I flipped that second fraction. So I have X squared plus 5X plus 4 over X squared plus X minus 12 times 2X squared minus 6X over X squared minus 1. Then I factored everything. So I got X plus 4 times X plus 1 over X plus 4 times X minus 3, 2X times X minus 3 over X minus 1 times X plus 1. Then I simplified what I could. So I saw that X plus 4 over X plus 4 cancels, X plus 1 over X plus 1, X minus 3, and X minus 3. So I'm left with 2X over X minus 1. So my restriction is obviously in the answer, we have 1. But then we also have to consider the other factors that canceled out. X plus 4, so X can't be negative 4. X minus 3, so X can't be 3. And X plus 1, X can't be negative 1 either. All right, so hopefully our answers match. Good work. All right, so let's do a challenge problem now. 6x cubed minus 6x squared over x to the 4th plus 5x cubed divided by 3x squared minus 15x plus 12 over 2x squared plus 2x minus 40. This is a fraction in a fraction, right? So this looks scarier than it is, because what does a fraction bar really mean? Doesn't that thing really mean divide? So what if we rewrote this as 6x cubed minus 6x squared over x to the 4th plus 5x cubed divided by 3x squared minus 15x plus 12 over 2x squared plus 2x minus 40. Well, hey, now we know how to deal with this. This is just like part A and B. So I'm going to change it to multiplication and flip the second fraction. And I'm going to leave the first one alone. All right, let's factor and then simplify. So 6x cubed minus 6x squared. If you want to finish this problem on your own, press pause and then press play and check your work. If you want to solve it with me, then let the video roll. So 6x cubed minus 6x squared. They both have 6x squared. So I'm going to factor out a 6x squared, and I'm going to be left with x minus 1. X to the 4th plus 5x cubed. They both have an x cubed. I'm going to be left with x plus 5 times. All right, 2x squared plus 2x minus 40. I can factor out a 2, and I'll be left with x squared plus x minus 20 over 3x squared minus 15x plus 12. They all have a 3, so I'm going to factor out a 3. 3x squared minus 5x plus 4. 2, 3. All right, so we can factor these guys. So x squared plus x minus 20. X times x gets me that x squared. The 20, let's see, factors of 20, that add or subtract to get us 1 would be 4 and 5. I need a positive 1x, so I'm going to have a positive 5 minus 4. Let's see, x squared minus 5x plus 4. X times x will give me x squared. 4 factors of 4, 1 and 4, 2 and 2. I need to get negative 5, so I'm going to use 1 and 4. And I'm going to have negative 4 and minus 1 to get negative 5 in the middle. All right, let's see what we can simplify. Let's see here. So x minus 1 and x minus 1. X plus 5 and x plus 5. X minus 4 and x minus 4. Okay, so 6 divided by 3 is 2. So that becomes a 2. And then x squared over x cubed. So x squared is really x times x. And x cubed is really x times x times x times x. So 2 of these x's will cancel. So what I'm left with here is 2 times 2 is 4 over x times everything else canceled. So we're just left with 4 over x. Oops, I forgot my restrictions. So x can't be 0, because if we plugged in 0 for x, we would get 0 in the denominator. But it also can't be, because of x plus 5, it can't be negative 5. Because of x minus 1, it can't be 1. And because of x minus 4, it can't be 4 either. So our final answer is 4 over x with the restrictions. X cannot be 0, negative 5, 1, or 4. Because all of those numbers would give us a 0 in our denominator. And we can't divide by 0, so that's not allowed. So the problem wasn't too bad. It just had a gazillion steps. All right, so now you're gonna do your extra practice. When you've got that submitted, you're gonna hit the ask for help button, and I'll jump into your breakout room with you and go over your answer. Thanks for your hard work today.